Hi everyone, welcome to our lecture on interpreting probability. In our past lectures on probability, we've seen the mathematics of probability. In this class, we're going to do something a little bit more philosophical. We're going to think about, well, what do we mean by probability? There's a really nice quote by Bertrand Russell, which was from a few years ago, admittedly, but I think captures the spirit of people thinking about probability. And the quote is the following: "Probability is the most important concept in modern science." That's true, especially as nobody has the slightest notion of what it means. So he might be exaggerating a little when he says people don't have the slightest notion, but as we'll see, trying to make precise what we mean by probability is quite difficult and requires some philosophy. So you may notice that we say things like, global warming is probably caused by humans. Biden will probably win or lose the election. I will probably pass this class. And the probability of a fair coin landing heads is 1/2. Now in all these we say probability, likelihoods, right? But what do we mean by probability? And here's where we get to the philosophical interesting part. Historically, there's been a number of distinct but related concepts that have been associated with the word probability. Now I should note here that what I'm going to say is a huge simplification of a very complicated literature, right? There's been a lot of work done on this, and I'm just summarizing in very broad strokes this literature in a 15 to 20 minute lecture. So take everything I say with a grain of salt. There's a lot of nuances that I won't be able to cover, but I think broadly most people would agree that there are at least two branches or two distinct views of what it means for what probability means. The first is that probability is subjective or personal, and this is the view that probabilities are just degrees of belief. So by assigning a probability to a statement means that the person uttering the statement or someone else might have a particular degree of belief in that statement. And this is a view that we're actually going to take in, and of course we'll get more into it. But the second view is the objective view. And this is the view that probabilities are kind of out there in the world. And often this is cashed out as relative frequencies. So to say that a statement has a certain probability is to say that it has a certain relative frequency of occurring. Now, these two views, they agree on the mathematics of probability, right? Nothing I've told you so far and that we've seen in the mathematics of probability is going to be affected by the interpretation. But these views disagree on what probability means. And as we'll see, that's going to be important for how we use it. So let's first get started with the objective view. So let's start with the frequency view. So it's good to start in these cases with a question. So what does it mean to say that the probability of a coin will land heads? Well, under the frequency or objective view, this depends on how often the coin actually lands heads. And this is what's called its relative frequency. So, in other words, objectivists think that there's a certain fact about the world, about how often, for example, a coin lands heads. And more generally, they think there's a fact about the world about which probabilities or which frequencies a particular statement or event might have. But this view has a lot of challenges to it. You might think that it's the most intuitive view, right? Well, what does it mean for the probability of a coin to land heads? Well, it's just how frequently it lands heads, right? That seems simple. But it becomes much more complicated. There's a lot of challenges to this view. The first challenge is that it doesn't seem to apply to all statements that we think have a particular probability, right? For example, what does it mean to say that the probability of the statement the dinosaurs were wiped out by a meteor is 90%? So note that here, this is very different than observing 100 coin tosses and then saying, well, the probability is just of it landing heads is just the amount of times it lands heads over the amount of times it was tossed, right? The dinosaurs were only wiped up once. It's not an event that you can observe a lot of occurrences of, right? So this is the first challenge to the frequency view. It doesn't seem to apply to all statements we think should have a probability. So just to recap, this objective of frequentist view equates probability with relative frequency. Here's another challenge. So the challenge can be posed as a question, which is, what sequences are we actually talking about? Suppose you and two other friends want to figure out what the probability is that a coin lands heads, and each one of you flips the coin. And you have the following three graphs, right? Each one representing the coin flips. Perhaps your friend flips the coin and it lands 36 times on heads and 62 times on tails. That's at the top part. Then you flip and it lands 48 times on heads and 52 times on tails. That's your flip in the middle. And then the other friend flips it 100 times and gets 54 heads and 46 tails. So note that here, we all, I think, have the intuition that the coin is fair, that this is a coin that should have a 50% chance probability of landing heads and 50% chance probability of landing tails. However, we have three different sequences which are all compatible with this notion of having half and half probability on heads and tails, right? Note that the top one has only 36 heads and 62 tails. But that's compatible with the idea that the coin has a 50% chance of probability of landing heads and 50% chance of landing tails. So what kind of frequencies are we talking about? Often, what objectivists do to kind of sideline this challenge is that they say, well, it's long run frequencies. You have to flip the coin for a really long time. The problem with that is that even then, you don't get this perfect 50-50, right? All you have to do is flip it have an odd number of flips, and you won't have this perfect 50-50. Another way that they try to sideline this issue is to say, well, let's appeal to hypothetical long-term frequencies. But here's the third challenge, which is hypothetical frequencies don't really resolve the issue. Again, hypothetical frequency is to say, well, suppose you flipped the coin 1 million times, or even an infinite amount of times, and that would be your probability. But that's really odd to appeal to hypothetical frequencies. First of all, it's circular. We're saying that the probability is the most probable hypothetical frequency. Because what the hypothetical frequentist here is doing is saying, look, of course you can have these different frequencies of maybe 36 heads and 64 tails. But if you flip the coin 1 million times or 10 million times or even an infinite amount of time, you would probably get half and half probabilities. But that's weird because you're appealing to a notion of probability to determine this. The second problem with appealing to hypothetical frequencies is that we can observe actual frequencies, which I think is where the force and the intuition for trying to appeal to frequencies is that we can actually observe frequencies. However, we can't observe hypothetical frequencies. And thirdly, is that scientific theories, we would want to assign probabilities to them, right? Scientific theories are never 100% certain, but scientific theories aren't the sorts of things that have frequencies. So with these challenges in mind, and I'll link to an article that goes through these in more details. If it'll be optional if you're curious. It's very interesting. But this will be enough to motivate you that we're not going to appeal to this relative frequency view of probability, but rather we're going to appeal to a subjective or personal probability view. And this is a view that probability is degrees of belief. So what do subjectivists or the personalists, if you want, think that probability is? Well, this is a view that probabilities are ultimately about the beliefs of an agent. So, for example, you might have the belief that you will pass the test with a 0.95 probability. Or you might have the belief that global warming is made by humans with a 0.98 probability, right? You're almost 100% certain. This, I think, is also a pretty intuitive view. But there is a significant challenge, which is that it takes away the objectivity of probabilities. And remember that science is an inductive endeavor. But if we're saying that probabilities and our inductive reasoning is subjective, then are we saying that science is not objective? Because remember that we want our inductive logic to help us assign inductive probabilities to scientific arguments, among other kinds of arguments. So really, are we saying that science is subjective and kind of that anything goes? Well, no, of course we aren't. Observation evidence-based reasonings are the keystones of science. They're supposed to separate the scientific method from other ways of viewing the world, like superstition of faith. Now, so how is it that the scientific method fits into this picture where we allow subjective probabilities to come into play? In other words, where we're allowing to say, well, science is just what the agents believe about the world. It's not necessarily an objective fact. Well, remember that we have a way of formally determine how we should update our beliefs given a piece of evidence. Right? That's what we called conditionalization, which is this formula over here, which is that your new probability or your new beliefs in a particular hypothesis or a particular statement, H, is going to be equal to your old probability or your old beliefs given the piece of evidence. So visually, you start out with your beliefs or your degree of probability in H. You observe, or I show you evidence E, and what this formula says is that the new probability or your new belief in H is going to be this probability of nu of H. And how do you get that? Well, you get it by getting the probability, your old probability of H given the new piece of evidence. Now, I just want to make crystal clear that we're not saying that anything goes. That's not at all what the subjectivist is saying. The subjectivist is saying, look, we don't need to claim something so strong as to say that there are objective probabilities in the world. What we're doing is claiming something much less strong to say, look, we don't need that. All we need is to say that probabilities are what the agents believe. And it's not that anything goes. There's rational and irrational ways of updating your beliefs. And as we'll see in the next lectures, the rational ways of updating your beliefs is in a way that conforms to probability theory and in ways that you update by conditionalization. And we'll see why that's the case, why that's a rational case. But I just want to make that extra clear. So let's look just at a last example as to how the frequentist and the objectivist might differ. So suppose that weather forecasters, they look at a huge amount of data from weeks that are similar to this past week, and in that data, 30% of those weeks were followed by rain. And so the forecasters conclude that the probability of rain tomorrow is 30%. So what would each of the views that we saw say? Well, the frequentist or the objectivist, they will claim that it's a fact about the world that given the information at hand, the probability of rain tomorrow is 30%. They think the strongest view thinks that's kind of a metaphysical fact about the world, that this is a probability. Whereas the subjectivist will think that because there are all sorts of judgment calls made, what judgment calls are being made? Well, which data to include? What measure of similarity between the data you include and this week counts, and so on. And so what the subjectivist says is that the claim that the probability of rain tomorrow is 30%, it only states what weather people believe. It doesn't state the objective fact in the world. And perhaps the strongest view of the subjectivist, which you don't have to hold on to, thinks that there's no such thing as probabilities in the world. Okay, on that note, I hope you have at least somewhat of a good idea between these two views. Again, the objectivists think that probabilities are objective, in other words, that they're in the world, whereas the subjectivist thinks that probabilities are kind of in the head. They're not necessarily in the world, or at least the probabilities that we care about. Now, I just want to end with saying that this distinction between objectivists and subjectivists, there are some practical applications. And actually in statistics, there are these two different camps between frequentists and perhaps Bayesians, which are the subjectivists. Now, in our class, we won't be able to look into that, but if you're curious, obviously send me an email or just read on it yourself. It's fascinating. With that said, thank you for watching.